All right, hello. Let's start off our next lesson that we have to do. And this lesson is going to be about, well, I shouldn't really say what the lesson is going to be about yet. Let's first solve the questions that we have to do. The first one that we're going to look at is exercise 1. And the question was x to the fourth power plus 7 equal to 6x squared. And we have to work that out. We just have to turn it into the form of a quadratic. So let's rewrite it first off. I'm going to write this as x to the second power raised to the second power plus 7. And I'm going to put minus 6x to the second power. And I'm going to put that in a bracket as well and equal to 0. I'm going to say let x equal x to the second power, and I'm going to get that x squared plus, well, actually I'm going to put in negative 6x next, and then plus the 7 equal to 0, and that will be the quadratic I need to work with. Alright, so let's go down to the next one. Second one is 5 over x equal to 2 minus 4 over x squared. Now, there's two ways you can go about solving this. You can multiply throughout this entire thing. You can multiply this entire thing by x squared, or you can just simply factor out 1 over x. I like to, it doesn't really matter to me actually. I have no preference for either. So let's work, I'm going to do both ways actually. Let's do both ways. So I'm going to do one in white, and I'm going to do, I'll call this method 1. Right, and this method I want to factor out. So I'm going to start from the equation and I'm going to rewrite first off. I'm going to rewrite it as 5 into 1 over x close bracket equal to 2 minus 4 into 1 over x, and I'm going to square that. And then I'm going to say let x equal 1 over x, and I'm going to get that 5x equal to 2 minus 4 in x. Let's write this differently, x squared. And then I'm going to make everything on one side. So I'm going to have 4x squared plus 5x, and then I'm going to minus 2 equals 0, and that will be my quadratic. The other method I can do, as I said, is I can multiply everything by x squared. So I'm going to do that now. So I'm going to put method 2. I'm going to multiply everything by x squared. So I'm going to have here 5 over x multiplied by x squared, and then I'm going to have equal to x squared into 2 minus 4 over x squared. Right? With this, I'm going to cancel 1 here, and I'm going to get 5x remaining. With this, I'm going to get equal to 2x squared, and then I'm going to put this over into here, and I will get minus 4. And then I make subject to the formula again. I'm going to get 2x squared minus 5x minus 4 equals 0. And both of these quadratics, this one here and this one here, both of them will give you the same answer when you work it out. They look different now, but remember this x here is representing 1 over x. Alright, so at the end of it, when you find the solution for x here, if you take this answer over here and you invert it, you should be able to get the same answers in both of them. Alright, let's look at question number 3. Just give me a moment, let me just find this here. Right, yeah, question number 3. So question number 3, third example problem that we have. Let's see. We're going to get 3 2x plus 7 equal to 10 into 3x. Right. I'm going to rewrite this again, and I'm rewriting it as 3 to the power of x squared plus 7 equal to 10, and then 3 to the power of x. And I'm going to say let x equal 3 to the power of x, and I'm going to get an x squared plus 7 equal to 10, and then I'm going to put that x on the end here actually. Right, and then make everything on put everything on one side, and I'm going to get x squared minus 10x from both sides, and I'm going to get this, and then plus 7 equal to 0. That's number 3. Let's do number 4. Number 4 is the root of x plus 3 equal to x. And I'm going to rewrite this entire equation. I'm going to have root of x plus 3 equal to root of x, and I'm going to square this, and I'm going to say let x equal the root of x. So I'm going to get x plus 3 equal x squared, and put everything on one side. I'm going to get x squared minus x minus 3 is equal to 0. We go on to the next page, and I'm going to do number 5 now. So example 5, and we have 2 cos squared theta is equal to 5 cos theta minus 2, and from there I'm going to rewrite, and I'm going to get something like this: cos theta squared equal to 5 cos theta, and I'm going to put that in bracket as well, and I'm going to let it doesn't matter, let me just use something different this time. Let me use y. Let y equal to cos theta, and I will have 2y squared equal to 5y minus 2, and put everything on one side. I'm going to get 2y squared minus 5y plus 2 is equal to 0. Let's go on to number 6. Example 6. And example 6 was x to the 6th power plus 4 equal to 5x to the 3rd power. And rewriting, I'm going to get, I'll write everything over in terms of x to the 3rd. So I'm going to have x to the 3rd power raised to the 2nd power. And this you're going to learn more about when we do more on indices. Plus 4 equal 5x to the 3rd power. And I'm going to say let x equal x to the 3rd, and I'm going to get x squared plus 4 equal to 5x, and then I'm going to put everything on one side. X squared minus 5x plus 4 equal to 0. Alright, let's go into number 7. Number 7 is 2 over x plus 7 equal to 3 over x squared. Again, you have 2 methods you can do. I'm just going to do a substitution method and keep working with substitution. So I'm going to write this as 2 into 1 over x plus 7 equals 3 into 1 over x squared. And then I'm going to just let x equal 1 over x, and I'm going to get 2x plus 7 equal to 3x squared. And put everything on one side. I'm going to get 3x squared plus, sorry, not plus, minus x minus 2x, and then minus 7 equal to 0. Okay, that's that. And let's go to number 8. Number 8 is 4 to the power of 2x plus 1 minus 20 into 4x equal to negative 16. So let's rewrite this a little bit. We're going to have 4 to the power of 2x multiplied by 4 to the power of 1. Again, you'll learn this in indices when we start doing the indices laws. So minus 20 into 4 to the power of x equal to negative 16. I'm going to write this over here. I'm going to just erase this and write it over x to the 2nd power. Right? So now I can say let x equal 4 to the power of x, and we're going to get x squared times 4 minus 20x equal to negative 16. Put everything on one side. We get 4x squared minus 20x plus 16 equal to 0. Example number 9. Example number 9, let's see. We have root of x plus 5 equal to 2x. I'm going to rewrite everything in terms of root x. So I'm going to say root x plus 5 is equal to 2 root x, and this will be squared. I'm going to say let x equal to the root of x, and we're going to get that x plus 5 is equal to 2x squared, and I'm going to just rewrite everything and put it on one side, so I'm going to get 2x squared minus x minus 5 equals 0. And then I think I have one more. Let's do number 9. No, number 10. So example number 10. And example number 10 was 3 sine squared x plus sine x equal to 4. And we can rewrite this as 3 into sine x squared plus sine x equal to 4. And I can just say let I would use y if I want y equal to sine x, and we'll have 3y squared plus y equal to 4, and I put everything on one side. I get 3y squared plus y minus 4 equals 0. Alright, and those are the 10 questions that I gave you in the last lesson to do. Now we're going to move on to today's lesson, and we just start on a new page. Today's lesson is going to be about relating the quadratic coefficients to the roots of the quadratic that you have. So let me just put that title here, relating quadratic roots and its coefficients. Right? The objective for the lesson today comes straight out of the syllabus as well. Objective is to use the relationship between the sums and product of the roots and the coefficients of, and then we have a quadratic equation. I'm going to write that quadratic equation in pink so that you can see it properly. We'll have ax squared plus bx plus c. Right, so this is the quadratic that we're talking about here. Oh, and I forget to do one thing, which is equal to 0, so I'll just put that there, equal 0. Right, and then let's start this lesson now, right? Relating the quadratic roots to the coefficients. So you already know how to solve quadratic equations. We already solved quadratic equations many times, and we use 3 different methods to solve those quadratic equations. And now what I want to do, as I say, is show you the relationship between the roots that you find and the coefficients of the quadratic equations that you solve, right? And this relationship that we're going to look at is useful when it is that you want to make sure that the answers that you get when you solve is correct. That's one. And it has real-world applications in terms of modeling. For example, in projectile motion, the roots of a quadratic would often represent the time when the object was launched and the time when the object lands. And once we know those 2 times, then what we can do is we can take those roots and we can construct the entire quadratic model that describes the object's motion as it's moving through the sky. And as I said, projectile motion is supposed to be like meow. And then you have here your launch time, I'll call that T1, and then your landing time, T2, right? We can get this entire projectile motion here. We can get this entire thing just by knowing these 2 roots and this equation, okay? Well, this relationship. And once you have the model, right, which is the quadratic equation, once you have the model, you'll be able to analyze the key features of the trajectory for the projectile that you have of interest, right? Now, this can be used, this relationship can be used in any situation that you know 2 root positions. As long as you know 2 root positions, you can use those root positions to develop a quadratic that will define the situation, the system that you'll observe in, which will define the system. Okay. The first thing we want to do is we want to do a derivation to show the relationship between the roots and the quadratics. And what we're going to do is we're going to start from the roots itself. Okay, so let me just start the derivation here. So I'll just name it relationship derivation. Right? So we call it the relationship derivation. I'm going to write in a smaller font. First thing you're going to have to do is you're going to have to assume the roots are alpha and beta. Now this is the form that you would see it is written in the syllabus. Okay. So we're going to assume that the roots are alpha and beta. So that means that x is equal to alpha and x is equal to beta. Now, these values, when you substitute them into the quadratic, you get a 0, right? If I take alpha and I have my, and I'm just going to write this in yellow, if this is not part of the derivation, but if I have my function of x, right, and I take alpha and I put it inside of this, and I get 0, I'm supposed to get 0, that means that it is the root of the equation. That's 1. And 2, it also means that if I use the factor theorem, using the factor theorem, it means that x minus alpha and x minus beta are going to be factors of the quadratic equation, are factors of the quadratic, right? And the quadratic, therefore, can then be written as, right here, so the quadratic can be written as, we're going to write it as x minus alpha and x minus beta, put it equal to 0. Now, when you have a quadratic, not all of your quadratics are going to start with the first coefficient being 1, right? Let me just write that. However, not all quadratics has a equal 1. And the a I'm talking about is this a right here. You would never find a case where every single time this here would be equal to 1. You're bound to have some kind of value here. So we have to take that into account. Okay. So if it is that a is not 1 in front of the x squared, we multiply by k in front of x squared. So multiply by a factor k, right? So if we multiply by a factor k, the quadratic equation becomes k into x minus alpha into x minus beta equal to 0, right? Now that is our quadratic equation, just from the roots alone. This factor here is a non-zero factor, where k is not going to be equal to 0. And k can belong to any integer or whole number, real number, right? It can't be 0. So we have this function here. What we're going to do now is we're going to try and see if we can write that function in the form of this. If we can write this function in that form of this here, then we should be able to get something to compare. So we're going to start expanding. I'm going to expand this function here. So I'm just going to say expanding 1, right? You know what? Let me just label this here. I'll just call this 2, because later on I'll need a reference, right? So expanding 1, actually I wouldn't even need to name it 2. Let's just expand. So expanding 1, we say that k is here, and this inside of this inside of here, this piece inside of here, is going to give me x squared minus alpha x minus beta x plus alpha beta, close bracket, equal to 0. Multiply everything throughout by k. I'm going to get kx squared minus k alpha x minus k beta x plus alpha beta equals 0. And then what am I going to do? I'm seeing here that I have an x squared. I'm seeing x here and x here. So I can factor out this x here and here. Right? Let's do that. So I'm going to rewrite this. I'm going to say kx squared. I'm going to minus k in front here. And at the side, inside of here, I'm going to have alpha plus beta, close the bracket. And then I'm going to put this x out on the back instead of the front where it would usually factor it out. And then I have plus alpha beta equals 0. Now, if you look at this here, you would see that this starts to look a little bit like this. Right? We're seeing that it's starting to look a little bit like it. So what we can do is we can comparing to the general form of a quadratic, we have that ax squared plus bx plus c equals 0. We can compare and we can see a few things, right? We can see right away, and I think I will just try and see if I can make the font larger, change the color a little bit. And I'm going to look at this here. I can see that kx squared here and ax squared here compares to each other. And I can see that minus k into alpha plus beta, close bracket, x, compares to plus bx. And I can see that plus alpha beta plus c compares to each other as well. All right, so let's do those in 3 different colors. So I'm going to see here we get, and I'm going to start off with the yellow one. We can get that ax squared is equal or comparable to kx squared. Since that's the case, we can see right away this will cancel with this and tell us that a is equal to k, or k is equal to a. That means anytime we have a k further, we can replace that k with, I'll leave out a k here and a k over here. Let me just put this in pink, big pink, here, k here, right? So we can see right away that this here, anytime we have a k, is going to be equal to a. So let me just write this, minus k into alpha plus beta x. So let's look at that orange one. Minus k into alpha plus beta x is supposed to be equal to bx here, right? Now, since k is equal to a, we have minus a into alpha plus beta x equal to bx. We can cancel this on both sides since it's a factor on both sides. And then we can make alpha plus beta the subject of the formula, and we'll get that minus b upon a is equal to the sum of the roots. So the sum of the roots is equal to, it's going to be equal to minus b upon a, right? Let's go on to the last part of it, which is plus k alpha beta plus c. So we have plus k alpha beta is equal to c. And we know right away that k is equal to a. Since k is equal to a, then we have a alpha beta is equal to c. So that means alpha beta is equal to c over a. And that there is the final results that we're looking for. And I'm going to circle these here, this one here, and this one here, right? Those are the two that we're looking for, okay? And I'm just going to write it in green at the bottom down here. We see in right here alpha plus beta. We see in alpha plus beta is equal to minus b upon a. and we're seeing that alpha beta is equal to C upon A. What does this mean? This means that the sum of the roots is equal to minus B upon A, and this here means that the product of the roots is equal to C upon A. Now, these have a name, and I'm just going to write it here. These are called, I'm going to say Vietas. I'm not sure how to pronounce it. If I pronounce it wrong, I'm sorry. Mullers for a quadratic equation. Right? And then we're going to start, so now that we have this, the sum of roots and the product of the roots relationship with the coefficients, we can verify its usage when it comes to verifying the solutions that you obtain for a quadratic equation. So let's say from an example, right? Let me just put EG instead of EX, right? So from an example, and I'm saying example 1, right? Example 1, we're going to call this a verification. Verifying that it works. So we're going to say consider the quadratic. I want something simple, so I'll go with something like this: minus 5x plus 6 equals 0. Right? Let's factorize it. We know that 1 by 6 is going to be 6, and I'm going to break those up into factors of 1 times 6 and 2 times 3. And the one that I can say works is this one, because if I multiply it and I add it, so I multiply it, I'm going to get positive 6, and if I add it, I'm going to get negative 5. So this is what I'm going to use to split. So I'm going to say x squared minus 2x minus 3x plus 6 equal to 0. And then I'm going to have here x into x minus 2, and then minus 3 into x minus 2 equals 0. And I'm going to have x minus 2 as one of the factors, and x minus 3 as the other factor equal to 0. And we know now that so the roots alpha and beta are, just put that, alpha and beta, alpha is equal to 2 when I put this equal to 0 and solve. And I'll get beta is equal to 3 when I put this equal to 0 and solve. Right? That's straight out of the factor theorem. Right? Now, let's verify that it works. Right? So let's verify that it works. We're seeing that we need, and I'm going to put it in big here, x squared minus 5x plus 6. Right? We need this here, which is the minus 5, and this here, which is the 6. Right? And let's see what we get. So we're saying alpha plus beta would be equal to 2 plus 3, which is equal to 5. Now, remember, we're looking at alpha plus beta is going to be negative of b over a, right? It's going to be negative of b over a. So right away, we can see that this here is just going to be negative 5, right? And you know what? This is not going to be seen easily. Let me do this a different way. What I'm going to do is I'm going to take this quadratic here. I'm going to write it in the form of, I'm going to have it written in the form of this, and that way you'll be able to see it easier, right? So let's do that. So let's see. I'm going to take here, I'm going to say x squared minus, open bracket, alpha plus beta, close bracket, x plus alpha beta is equivalent to x squared, I'm dividing throughout by a, plus b upon a x plus c upon a, right? So we're seeing right away, for us to get this plus on the inside here, we're going to have to take the minus of whatever alpha and beta is to get that value that we need, right? So when we take alpha plus beta and we get 2 plus 3, which is 5, remember there's a minus sign out in front of it here. So that is going to be a negative 5. So we have so far x squared minus 5x. And then we take alpha beta, which is 2 times 3, 6. At the end here, we put that in and we get plus 6. So we verify right away, a very quick verification, that our answers of 2 and 3 are correct because we get back the quadratic equation as soon as we find the sum and the product of the roots. Okay? And that is basically all you have to do when it comes to verifying that your answer is correct. All right? So let's look at some examples of how you would use this relationship. We're going to do about, I don't know, maybe about 3 examples of how you would use it. And then I'm going to give you your exercise to do for today. All right, so let's do another example. You know what? I prefer exercise. I prefer write EX. I don't know why. Just leave it as EX. Find the sum and product of the roots of, we're going to say 2x squared plus 5x minus 4 equals 0. And let's start by first isolating everything that we need. We know that alpha plus beta is equal to minus b over 2a. Sorry, b over a. So which means I'm going to take minus, b is 5 in this case, and then a is 2 here, so we get minus 5 over 2. I'm just going to write a, b, and c here so you know what this value is. And then we have alpha beta is going to be the product of the roots, which is going to be c upon a, and we know that c is minus 4 and a is 2, so we get minus 2 here as the product and the sum of the roots. All right, let's look at the next one. Let's say example 3, and I think this one has 2. Example 2. If the equation 4x squared minus 8x plus 3 is equal to 0 has roots alpha and beta, find 1 over alpha plus 1 over beta. Now you can go about finding the roots and whatever and then find 1 over alpha and 1 over beta, but the faster way to do it would just be, but let's make the assumption that can be solved so easily. Let's do it the other way, right? Which is to assume the roots. So we know that alpha plus beta, which is the sum of the roots, is going to be minus b upon a. And from my quadratic, this is a, this is b, this is c. So I will get minus b upon a is minus of minus 8 divided by a, which is 4. That is 8 over 4, which is 2. And then we have alpha beta, which is going to be c over a, and that will be 3 over 4, so that is 3/4. I don't need to reduce that, that says that is. And then let's go about rewriting this or working with this a little bit. Use some algebra and rewrite this a little bit so that you can have these inside of it. So we're going to have 1 over alpha plus 1 over beta, and we can use our fractions rules and realize that we find the product of these at the bottom, and we'll get the LCM. So we say alpha beta, and this here will be beta plus alpha, and we can see right away that if we take the sum of the roots, which is alpha plus beta on the top, and divide it by the product of the roots, alpha beta, that is going to be equivalent to this 1 over alpha plus 1 over beta. So we're going to take, let me just write that on a new line. We're going to take 2 and we're going to divide it by 3 over 4, which would mean, just put an equal sign instead, which would mean 2 multiplied by 4 over 3, which is 8 over 3. And that's the result of it. Okay. And then finally, I'm going to do a last one. Let's see, example 3. And we're going to say from, no, form a quadratic equation whose roots are twice the roots of x squared minus 3x plus 2 equals 0. Right? First off, we're going to write the sum of the roots and the product of the roots, which would be very easy in this case. Right? So we can write this and see that in the form here, sum of the roots, let's say alpha plus beta, is equal to minus b upon a, which is minus of minus 3 divided by a, which is 1, which is just going to be 3. And the product of the roots alpha beta is going to be c upon a, which is just going to be 2 upon 1, which is just simply 2. Now you can see this right away. If I take the negative of this, that will be my alpha plus beta. And if I take this here, that is the product of alpha and beta. And we can only do that because this value in front here is 1. If it wasn't 1, you couldn't do that. Since it's 1, you can do that. Right? So let's now look for new roots. The new roots, I'll just put this roots, right? The new roots is twice that of the roots for the original equation. So I'm going to take twice of alpha and twice of beta. Those are my new roots. Okay. Now, any quadratic equation can be formed as long as we have the sum and the product of the roots. So if this and this is my roots, then the sum of the roots, is going to be equal to 2 alpha plus 2 beta, and that will be equal to 2 into alpha plus beta, which is very simple for me to do because alpha plus beta that we had before is equal to 3. So I'm going to say 2 by 3. So this is 6. And then we have the product of the roots. Product of roots is going to be 2 alpha multiplied by 2 beta. And then that would mean that we're going to have equal to 4 alpha beta. 4 alpha beta, I'm just going to have to take 4 and multiply it by 2 because alpha beta is 2. So we take 4 alpha beta and we get 4 by 2, we get 8. And then what we do is we form the quadratic. So remember, the quadratic is the general form of the quadratic. Let me just write it out here. The general form is going to be x squared minus sum of roots x plus the product of roots equals 0. So right away, I'm going to see x squared. So let me just write this out here. So hence the quadratic is x squared minus the sum of the roots is going to be 6, and the product of the roots is 8. So we have 8 equal to 0. Right? And that is the answer. X squared minus 6x plus 8 equals 0. So that is the new quadratic equation with roots that are twice that of the roots found in this equation. Okay? Now, that is the end of it. And if you want some more practice, I'm going to put some more practice questions on each thing here, and we'll solve it in the next lesson. So exercise, I'm going to put 1. So for the quadratic 3x squared plus 7x minus 2 equals 0, find the sum and product of its roots. And then for 2, you can say if alpha and beta are roots of 2x squared minus 5x plus 1 equals 0, I want you to find a alpha squared plus beta squared and b alpha minus beta squared. Let me just mention this quickly right now. When you're solving these, try and see if you can expand something like either, I'm putting it in white. Expand either alpha minus beta squared or alpha plus beta squared. Try expanding these two, right? Try expanding these two, and then you would get a relationship between this here and the sum of roots and product of roots. Try and expand these two. That's your hint in solving this one, right? Just like when we use a little bit of algebra knowledge and some of our fractions knowledge earlier to solve this problem here, where we saw that 1 over alpha plus 1 over beta is the same as saying the sum of the roots over the product of the roots, and we substitute the values and we get an answer. Try doing the same thing, okay? Expand this, and see if you can find an equivalence for this in terms of the sum of the roots and the product of the roots, and this in terms of the sum of the roots and the product of the roots. Okay, that's as much as a hint I can give you. I'll do it in the next exercise lesson then. Right? So in the next lesson, I'll solve that so you can see how it's solved if you're having a problem. Right? And then the final question is that the roots of a quadratic equation are 3 times the roots of x squared minus 4x plus 3 equals 0. And we want you to form the new quadratic equation. Right? And that will be it for this lesson. So if you have any questions, comments, issues, please let me know and I'll address them in the next lesson. Bye bye.